f of a. Well, f of a, and we did f of m yesterday. We were like, I don't want to make it, be silly, but that's all you do is take the x out and put in what? A. So I need to separate this though, because it's going to be with the brackets. So it's going to be 3a squared minus 2a plus 5. If you're subtracting a quantity, you got to put it in parentheses. You just cannot make it minus 3a squared and leave everything else. So that negative will essentially distribute to that whole second piece there. Well, we got to do a little bit of work here. A plus 3 squared, you got to FOIL it, right? So that becomes 3a squared plus 6a plus 9. I'll distribute in a minute. Distribute your negative 2, negative 2a minus 6 plus 5. And if you want to, we can...
Your attention, seventh graders, at this time, students, last names A with C. It's time for your health screening in the pod. Bring your eyeglasses and nothing else. Thank you.
Our biggest thing is a lot of times you forget or you don't subtract that second piece. You only do it to the first one. So make sure you distribute that negative to the whole thing. You still need to distribute the 3a squared plus 18a plus 27. And now everything else has already been distributed. Now all you have to do is combine like terms. But I got 3a squared and then negative 3a squared. So those add up to 0. Okay, those are gone. 18 minus 2 is 16. 16 plus 2 is 18. So that all ends up equaling 8. That's where the 18a comes from. Okay, so I got 18a, negative 2a, positive 2a. And now after that, I got 27 minus 6 is 21. Plus 5 is 26. Minus 5 takes me back to 21. So I get 18a plus 21. Okay? So we'll understand those concepts. So we applied in a little bit new situation. We did that yesterday and we did that yesterday, but now we're just putting it all together. All right, we're going to move into 2.5 properties of functions. And it's a lot, but it's not that intense. I mean, there's a bunch of little things we got to get through. But I don't think it's anything that's too bad. The hardest part tends to be the even versus the odd. And we'll get to that here in a minute. So we're talking about increasing or decreasing. Even and odd functions. Like I said, those tend to be the most difficult here. But after that, finding relative maximum, you're okay with that. I just want to hit it again. All right. Increasing function. I kind of got the graph on there to help you out a little bit. But at the top there, has to do with the mathematical definition. So like you can draw an increasing function, but what does it mean to state it mathematically? Well, here is your rule mathematically. If x1 is less than x2, then f of x1 has to be less than f of x2. So if x1 is smaller than x2, when you evaluate the function, the y value has to be smaller. That's how it's going to increase. And it's going to increase over an interval where any 2 points you pick at random, whatever 2 points it is, f of x, as long as x1 is less than x2, then the y values are less than. So that should go up there in that top in that little spot. What about a decreasing function? Okay, decreasing function, you know how to identify. Okay, it's going to go down from left to right. Mathematically, though, if x1 is less than x2, what's going to happen is f of x1 has to be bigger than f of x2. Okay, so you're going to have to get a smaller number when you plug in that second value. So that'll be the case for decreasing function. And a constant function, well, the constant function is a horizontal line. If x1 is less than x2, then f of x1 is going to equal f of x2. It got to be the same. Okay, for that. So increasing, decreasing, constant, can't have anything else. Now, functions can go from increasing to decreasing or decreasing to increasing, throughout its graph. All right, you got that figure there. What interval is that graph increasing on? Okay, and we're going to write that in interval notation. Okay, what interval is it increasing on? Well, you got to watch. Don't get fooled by that arrow. That arrow just says it goes in this direction. But as you go from left to right, this graph is increasing from negative infinity till it gets to this x value of -3. So it's increasing on the interval negative infinity to -3. Now, when we're talking increasing or decreasing, we're never going to use a bracket because at that point it kind of changes. And you cannot say at -3, you can't say it's increasing because you can't pick a point to the right of it. So we just go to that point and stop. Decreasing, well, decreasing is going downhill. It's going to be at 1, 2, 3, 4 to positive infinity. 4 to positive infinity. It's going to be decreasing. Whoops, move that up. Why did I put it there? Right there. Decreasing on 4 to positive. And constant in between. So from -3 to 4, it's constant. Yeah. Again, we're not going to put a bracket. Okay, it's not going to be increasing, decreasing, or constant at those kind of changeover points. Relative max, relative min. Okay. Relative max means that in an area, that is the highest point. If you say the word absolute max, that means it's the absolute highest point of a graph. So for this one here, you got to be careful. So, because sometimes you'll see the word absolute versus relative. If I put an arrow on these, you cannot say these are absolute maxes. Well, this one can't be because there's higher points. But this one you say might be. If that arrow keeps going up, that's not the highest point on the graph. To be an absolute max, it has to be the highest point on the graph. To be an absolute min, it has to be the lowest point on the graph. These are going to be relative maxes because in this area it's the highest point. So think of a peak and valley. Relative min will be a valley. Okay. All right, now that figure there, go ahead and draw that to the right, if you would. Okay, we're on that blank grid there. Okay, and just a little bit for notation-wise and just how to say things. How many relative maxes does this one have? Okay, Luke Candles, you look at that. How many relative maxes does it have?
2.
What 2 ones?
-3 and 3.5.
Okay, that would be the coordinates of this. So you would technically list this as, well, how many points have a relative max? Just the one.
Yeah.
So that is the coordinate. So it has one relative max, and this is how you word it. Okay, you have a relative max of 3.5 at x equals -3. Okay, the max is the y value. The relative max at 3.5. Where does it occur at? At x equals -3. How many relative mins does it have? Okay, it has 1. Okay, that point. So you say it has a relative min. Relative min of -1.4 at x equals 1.7. All right, look at that graph. Where's it increasing? Where's it decreasing? Okay, where's that graph increasing? Where's that graph decreasing? Okay, so just think through that for a second. All right, Sam, what do you think for increasing?
Negative and even -3.
Okay.
And then from 1.7 to infinity.
Okay, so negative infinity to 1 or to -3. Since there's 2, you put a union, we'll do union, and then from 1.7 to infinity. All right, so we're looking at here increasing as it goes from left to right. It's getting bigger. So it's going to go all the way to that point. That is the relative max. Okay, so that relative max, now it switches over now. It comes back here, the relative min, it's going back up. In between, okay, in between there is decreasing. So that is from -3 to 1.7. It's not constant anywhere. Okay, you don't have a horizontal line. So you get increase, you get decrease. And obviously we can have more than one interval where it's increasing, more than one interval where it's decreasing for that. All right, so identify difference between relative max. Now, absolute max, is that the absolute highest point? No. Absolute lowest point? No. So this one has no absolute maxes. There's a relative max, relative min. Peak has a value. Another way to word these, okay? If it's the value f of a is called an extreme value, okay, of f if it is either a relative max value or a relative min value. So they'll say, what are the extreme points? So let's talk about the extreme points, just a different way to word it. Then you identify the relative max, relative min. Turning point, well, this should make sense because at that point it's going to go, it turns from either increasing to decreasing. So a graph changes direction from increasing to decreasing or from decreasing to increasing. All right, so that's turning point. Good there? All right. So I think these are a lot of little things, like you know them, you've seen them, but I want to make sure we're good with them. All right, I want the relative max and relative min for this graph on your calculator. So if you got the graph, it's a little bit easy. So go ahead and graph on your calculator. You got a grid there, sketch it on there. I'll pull up my calculator in a minute. All right, now relative min. Pretty easy to find. What's that relative min? Okay, 0, 0. All right. The relative max, you know how to find that on your calculator. You remember how to use the techniques on your calculator. So what do we got? Negative x cubed plus 3x squared graph. No, I want to do that. Oh, there it is. Okay. So we got relative min at 0, 0. All right. I don't want to, you might be able to come close, but I want to make sure we're exact. How do we find exact the relative max? Okay, you remember how to do that? Brooklyn, you remember? No? All right. Nathan, you remember?
Yeah.
What do we do?
Second trace to get the calc.
Okay, yep, we go to the calculate.
And go to maximum.
And then we got 0, we got minimum, we got maximum. We want the maximum in this case. So we go to maximum. And it will tell you left bound. All you got to do is be to the left of that maximum point. Because it goes through a little procedure here. And I hit enter. And it right bound. I just need to be to the right of it. Okay, so those arrows should be pointing at each other in between at the highest or the lowest value. All right, good. Now, did somebody get anything different than that? I got 5 zeros and a 2, 3. All right. Alex, you get the same thing?
I forgot how to do it.
All right,
I
do
know
it
you
now.
said it.
Do it now. Do it now. What'd you get?
1, 5 9s, and 8 5.
All right, 1.999985. All right, be smarter than your calculator. What's the answer? Answer's 2. Why didn't it come? Why did you get 1.999999953 and I got 2.0000023? Why'd that happen? Calculator dumb? Okay. So be smart in your calculator. So it's 2-4. It goes through an algorithm. An algorithm is a procedure, and every now and then it deals with round off error. So your calculator is dealing with some round off error, so it rounds it off, and so it doesn't get it exact. You know it's exact because even if I go to my table says 2-4. So be smarter than your calculator. Don't put 2.00000 or whatever. Relative max is 2-4. Okay, relative max is 2-4. So I just want to make sure you see you saw that, and also that's how you get relative max, relative mins. You go to after you got the graph, second calculate, and zeros as well. Points of intersection. I'm sure you use them at some point at some time. Okay, even versus odd functions. Even versus odd functions. This will come up a lot. And it tends to be, it takes a couple times usually for everything to sink in. A function is even. Okay, and this is kind of your definition. Let me see here what yours. Okay, you got that top line. A function f is called an even function if for each x in the domain of f, negative x is also in the domain of f, and this is what you need to put in that first blank. F of negative x equals f of x. That is the key part. I didn't list the whole absolute definition. Okay, I just kind of condensed it. Now, I think the easiest way first time is just to give you an example of an even function. An even function is f of x equals x squared. Okay? And let's just graph that over there to the right. You got that graph over there. F of x equals x squared. You know it's a parabola. You know it opens up. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, parabola opens up in this case. What is that symmetric about?
Y-axis.
Y-axis. So the graph of an even function will be symmetric about the y-axis. So the graph of an even function is symmetric about the y-axis. All right, so here's what's happening for an even function. An x squared is an easy case here. When you plug in the number 2, we get back the number 4. If a function is even, when you plug in -2, what do we have to get back? +4. You have to get back the same answer. So -2, I get back +4. I'm making this up. If I plug in 1.3 and I get back -18, then what must be true? What other point do I know? All right, Alex, is that making sense? What other point would I know?
-1.3 and -18.
-1.3, I got to get back -18. Okay, so the positive and the negative values will give me back the same answer. Okay, that's an even function. Whatever those two values, got to be the same. Very easy case. You plug in -3, you get 9. You plug in 3, you get 9. Okay, an odd function. Okay, you got that jargon there, but at the end, this is what makes an odd function. If x is in the domain and -x is also in the domain, then when you plug in the opposite, you're going to get back the opposite answer. So f of -x equals the opposite of f of x. Go ahead over there and graph f of x equals x to the third power. That is an odd function. Okay, that is an odd function. So if you graph that and you just plug in points, really, if I plug in -2, I'm going to get -8, which is going to be a little bit off my screen, but at least I know where I'm coming from. -1, I get -1. 0, I get 0. 1, I get 1. And then 2, I get +8, which will be up here a little bit. But there's your graph for x cubed. What's that symmetric about? Not the y-axis, not the x-axis,
The y over x. Or x over y.
origin.
Origin.
That's not an option. It's symmetric about the origin. Okay, the graph of an odd function. Whoops. The graph of an odd function is symmetric about the origin. All right, so here's also what's happening. So in this case here, when I plug in 2, I get back 8 for x cubed. If it's an odd function, when you plug in the opposite x value, you're going to get the opposite y value. So I plug in -2, I get -8. Okay, that's always going to be the case. So for x cubed, if I plug in 3, I get 27. That means that I plug in -3, I get -27. So let me just make one up. If I plug in 2.8 and I get back -13, what must be true if it's an odd function? When I plug in -2.8, what must I get back? +13, okay? So -2.8 would give me +13, okay, for that. Not every function's even, not every function's odd. There's just some that are neither. Okay, so if I plug in 2 and get back 8, I might plug in -2 and get back 16. Okay, it's not even or odd. So let's take a look at how we show that. If f of x equals 3x squared plus, is that even? All right, I didn't really leave you room for that, so you should have a little bit of room before it says average rate of change. So see if you can squeeze that in there. Okay, forgot about that. I at least wanted to hit one example. Here's what you do. So if, and you can just pay attention to this first part. If, that's an awkward if f of -x equals f of x, then it's going to be what? It's going to be even. It is even. If f of -x equals the opposite of f of x, it's odd. The darn thing about math is you can't just plug in numbers. That's not good enough. You got to prove it for all cases, which means you got to plug in variables. So what we're going to do is we're going to take -x and plug it in for f and see what we get. So we got to evaluate f of -x. So f of -x is going to be 3 times -x squared plus 7 times -x. Now, what does that simplify to? That becomes a positive. That becomes 3x squared minus 7x. Okay, now you got to evaluate this. Is this the same as the original function? No, it's not. So that means it's not even, correct? Is it the opposite? Well, what does it the opposite mean? So negative f of x would be negative of the whole thing, which is 3x squared plus 7x. And if you distribute that negative, we would get this, negative 3x squared minus 7x. Does it equal that? No. So it doesn't equal f of x. It's not the opposite of f of x. So this would fall under which category? Neither. So this would be neither. Now you can plug in numbers to get an idea of what you're searching for, but to prove it, you got to plug in just the negative x. Okay, so f of -x does not equal f of x. It does not equal f of -x, or the opposite of that. So that would be a neither case. All right, so you got even and odd. Now we move into average rate of change. you just got two ordered pairs, and you got to watch how the wording of it. It says the average rate of change of f of x as x changes from A to B. Okay, this is going from A to B, but what order do they have here? They have f of B minus f of A over B minus A. So you got to go the second minus the first. So that's important. You can't switch it around. Okay, you can't be arbitrary. So that would be the case. F of B, then that you write that equation there on the bottom. Okay, flip it over. Now I kind of gave you the A here and the B here. It says find the average rate of change of f of x equals 0.5x squared as x changes from A equals 2 to B equals 4. Now you don't have that picture, you don't need it, but I'd like to give you, something to go by here. When you plug in 2 into this case, you get back 2. When you plug in 4, well, 4 squared is 16. Half of that is going to be 8. We get back the value 8. So the average rate of change is going to be f of B, I'm just going to rewrite this, minus f of A over B minus A. So f of B is f of 4 minus f of 2 over 4 minus 2. And what did we just say we get for 4? We get 8.
Attention, please. At this time, we need seventh graders with last names beginning with D through G. Please report to the pod for your screening and bring your eyeglasses. Eyeglasses only to the pod. Thank you.
Okay, this is really slow. Okay, we're going to give a fancy title, average rate of change, which is true. It's how much is changing from 2 to 4. But what we're doing is we're measuring f of B minus f of A measures the difference in the y values, which was 8 and 2, which is 6. And the B minus A measures the difference of the x values. No, I did that wrong, right? Hold on. Sorry. I hope you didn't copy that down. Because f of 4 is 8. F of 2 is 2, which is 6 over 2. That should be 3. Sorry about that. So you're really measuring the difference between the y values, f of B minus f of A. You're really measuring the difference of the x values. Now, it's going to be different based upon what you pick for A to B. It's not always going to be the same. So if I said A is 2 to B is 6, that average rate of change is not going to be 3. It's going to be a different number. Okay, so don't assume it's always the same. It's not a linear function where it's going to be the same for each one. All right, last thing we need to hit. It's called the difference quotient. Okay, for a function f, the difference quotient is f of x plus h minus f of x all over h. At this point, you're not going to understand this, and this is kind of a little bit of a lead up to calculus. Okay, basically all the first semester of calculus is based upon this little equation. Now, what we have to do is we have to make sure you can do the algebra behind it. Okay, so we got to do that part. So we're going to take this function and we're going to find the difference quotient. So we're going to do f of x plus h minus f of x all over h. Okay, so the difference quotient is f of x plus h minus f of x all over h. Think of this, make sure this is two distinct pieces. This is like we did the very, very, very first thing in class. F of a plus 3 minus f of a on that idea. F of x plus h means you take x plus h and you put it wherever there's an x. So it's 2 times x plus h minus 5. That is f of x plus h minus f of x, which is just the original function. You don't do anything to it. All over h. Okay, so this is f of x plus h minus f of x. Now it's a case of distributing and simplifying. Okay, distribute in the numerator, combine all like terms you can in the numerator. So when we do this, I get 2x plus 2h minus 5 minus 2x plus 5 all over h. 2x minus 2x is 0, right? Negative 5 plus 5 is 0. What's the only thing I'm left with? 2h. 2h divided by h, which becomes what? 2. So there's my difference quotient. F of x plus h minus f of x divided by h. For this one will equal 2. Okay, will equal 2. All right, let's get through this one. That was a linear. Honestly, it's easier. Throw in quadratic, this gets a little bit messier. Set process is still the same. Process is still the same. All right, f of x equals 2x squared minus 3x plus 1. We got to find f of x plus h minus f of x all divided by h. So f of x plus h, I'm going to put it in brackets. 2 times x plus h squared minus 3 times x plus h plus 1 minus f of x, which is just the original function, all divided by h. Okay, for that. Talked about this yesterday, and this is why. Yesterday we had x plus h squared, which is x plus h times x plus h. And what does that FOIL together to give us? Okay, you remember from yesterday, it's going to give us x squared plus 2xh plus h squared. This comes up a lot. Okay, if you need to FOIL it out, fine, but that's going to be that final case. So now I got equals, and I'm going to take this step. 2 times x squared plus 2xh plus h squared. Put that all in parentheses. Minus 3x minus 3h plus 1, and then distribute the negative. Minus 2x squared plus 3x minus 1. All over h. Distribute your two combined like terms. Two x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 all over h. Now when you're doing this, you should have things add up to 0. Okay. 2x squared minus 2x squared adds up to 0. I have a negative 3x and a positive 3x. I got a positive 1 and a negative 1. Now really I don't have any like terms to combine. Well, excuse me, the ones that add up to 0. After that, what am I left with? 4xh plus 2h squared minus 3h. Don't worry about reorganizing that. Just keep it in its order. If you do everything right, everything in the top has a what? H. That's going to cancel that h on the bottom. That should always happen. So technically, I'm going to factor out an h. 4x plus 2h minus 3 divided by h. Those h's cancel. And so my difference quotient of 4x plus h minus f of x plus h minus f of x over h equals 4x plus 2h minus 3. Okay. At this point, you don't know, nor should you know, how that even relates to calculus. We're just concerned, can you get that answer? Can you do the algebra? If you can't do the algebra, then you kind of get lost in the calculus. Okay. All right. I knew this was going to be a long day. Sorry about that. Or a long period. page 245 to 247. Like some of this is just like that increasing and decreasing, not bad. Difference quotient, you really need to know how to do. If you're not getting those answers right, we gotta make sure we go over. We will quiz after section 2.6, so probably Wednesday. If I think it's on the Canvas is Wednesday. I'll have to double check. I think it's a good one, right?